Hello and welcome to this video. In particular, we're talking about thermometers that work on the principle of thermal expansion. And right now we're talking about liquid and glass thermometers. In another video, we went through the theory behind liquid and glass thermometers. In this video, we're going to talk about the different types of liquid and glass thermometers, as well as the errors associated with liquid and glass thermometers. The types, well, there's the different types of immersions. We're going to talk about partial, total, and complete immersion. And then finally, we're going to get into special use thermometers, maximum and minimum thermometers. Before we begin our discussion about immersion type, we've got to define what the emergent stem is. And the emergent stem is that part of the thermometer that comes above the immersion line, if there is one that is marked on the thermometer. But more typically, it's the part of the thermometer that doesn't have either alcohol or mercury in it. In other words, the thermometric fluid. The different types of thermometers, there's partial, complete, and total immersion. Partial immersion, they're supposed to be immersed up to the immersion line, which is typically scribed or drawn on a thermometer. You'll see this on candy thermometers and other types of thermometers. Not very common in making meteorological measurements, though. A total immersion thermometer is one where you put the bulb and also the thermometric fluid, in other words, either the alcohol or the mercury that's coming up through the stem. Put that into the fluid that you're trying to measure. Once again, not something that we use in atmospheric sciences. In meteorology, we use complete immersion thermometers. What you're trying to measure is the temperature of the atmosphere, and the atmosphere typically surrounds the thermometer, so it's completely immersed in the fluid. In this case, the fluid is the atmosphere. So the complete immersion, the bulb and all of the stem, including even the portion of the stem that does not have thermometric fluid, in other words, the alcohol or the mercury in it. Most thermometers are complete immersion thermometers. If they're not complete immersion thermometers, then typically they have a marking on them showing to what portion they need to be immersed in the fluid that they're trying to measure. Other types of thermometers, special use thermometers, there's the maximum and minimum thermometers. As the name implies, the maximum thermometer measures maximum temperature. And it's mounted so that the bulb is a little bit higher than the column of either mercury or alcohol. So in other words, it's not necessarily flat, but level. It's just a slight angle where the bulb portion is higher than the stem portion. And then as the fluid rises, either the mercury or the alcohol, typically mercury rises in the thermometer, it pushes past a constriction. And that constriction does not allow the mercury to come back into the bulb. So it can go one way but not back the other. And when that happens, it traps the mercury at its highest point in the stem, and from that you can measure the maximum temperature. So what's remaining in the stem measures the maximum temperature. To reset the maximum temperature thermometer, what you need to do is take it off of its mount and then hold it by its stem and then sling it towards the ground, holding it very firmly so it doesn't go flying into the ground, but just kind of shaking it so that it pushes all the mercury back into the bulb. The minimum thermometer uses kind of a similar concept. Instead of a restriction in the capillary, instead it has a little index that moves back and forth with the thermometric fluid. Typically, in this case, this is alcohol. The little slider looks like a dumbbell. And what happens is as the temperature drops, the slider drops with the alcohol. And then on the way back up, when the temperature starts to rise, the slider has some friction in it and does not allow the dumbbell to move upwards with the alcohol. And the friction keeps the little index down in the bottom of the stem, and that's where you read the minimum temperature. This is an example of a minimum thermometer, and you can see between the temperatures in 60 and 70 is that little index slider. So it looks like your minimum temperature was probably around 60 degrees Fahrenheit on this. Here are the maximum and minimum thermometers mounted in a Stevenson screen, an instrument shelter. And you can always tell the maximum thermometer because the bulb is higher than the stem. And the minimum thermometer is just the opposite. The stem is lower, I take that back. The bulb is lower than the stem. Here's a list of all the different types of errors that you can have with liquid and glass thermometers. There are errors as a result of a rapid change in temperature, an irreversible error due to exposure to sunlight, also emergent stem error. We talked about if you don't have the stem in the fluid or if it's supposed to be in the fluid. Parallax error, just measuring it because you're looking at it from an angle. Incorrect division due to manufacturing defects, and believe it or not, that does happen. Adherence of spirit to glass due to rapid temperature changes. The fluid doesn't go up or down as rapidly. And then finally, this is the worst error that you can have with a liquid and glass thermometer. It's the breaking of the liquid in the column. In other words, you get bubbles or something like that. And your error can be anywhere from 5 to 10 degrees Fahrenheit or worse. I've seen worse. If you do get a break, like you see here in this image, a break in your liquid column, your thermometric fluid, then there are three ways you can correct that. Either you can heat the bulb, but don't put it in a very hot flame, otherwise it'll shoot out the top of the thermometer, the fluid. What you want to do is put it maybe in some boiling water and let that go up, and then cool it down under some cool water. Or you can sling the thermometer, once again similar to a maximum thermometer where you use centrifugal force to push the fluid down back into the bulb. Or you can tap the thermometer on a table, being very careful, to gently reunite the column of liquid. So those are some special use thermometers and also errors that you may see with liquid and glass thermometers.